What's going on, everybody? So this is for item number one on the calculus problem set. Uh, it's talking about how far do you need to travel on the concrete to minimize the total time that it takes you to get from point A to point B. First off, I went through and I did it without calculus real quick. So went through it, did 10 miles, it was 5 1/3, 5.0615 and 9 miles on concrete. Found a 6 miles on concrete, gave us the minimum, going down by 1. Then I went back through and I added point 0.1, point 0.2, point 0.3, point 0.4, found point 0.4 to be the minimum there. And here I was just taking total miles you traveled on concrete dividing by 3 because you're traveling 3 miles per hour on concrete. And then for distance C here, I knew this is 10 minus x, this is 4, so I used Pythagorean theorem to find C. So I found 6.4 miles on the concrete would minimize the total number of hours. But then I wanted to also do a little bit of calculus with it as well. So I know that this function here at the minimum, because this is the function of the total number of hours, and I know that it has to be between 0 and 10 because you can only go 0 miles to 10 miles total. Then I know that at the minimum value of this function, so on this red line over here, we know this is going to be so you can see there the minimum value on that red line is 6.422, which would give us the shortest length of miles that you would travel on concrete to get there in the shortest amount of time in 4.824 hours. Right? So I know you could check this using the derivative tests as well. Using the first derivative test, if for f prime of x here, so if you did, this is going to be the f prime of x, this blue line. That's just telling you the slope of every single point x on this line. So the slope here meets up right here, it's going down, so this means this line has negative slope, until we hit that minimum point, and then it comes back up and the slope goes positive. So you know that since this derivative line is concave up, you know we're going to be working with a minimum here because values are going to be greater on either side of the critical point that we found.